AP test this morning. So if we're writing the equation for this graph in number 1, you need to look at where the midline goes. And for this particular one, the midline has moved to here. So now we can take a look. This is the midline, I know, because it's the same number of units up as it is down, right? So I know that's the midline. And from that, I can tell that A needs to be 2, because the distance from 2 to there is 2 to 4 is 2 units. So I know that the beginning letter is A. Now I need to determine what B is. And remember, B is the period, all right, affects the period. So the normal period for cosine, and this is indeed cosine. How do you know this is cosine? Actually, there's several equations you could write, but the easiest one is cosine because it's at 1 here, not the origin that's moved up 2 units, right? So this is cosine, and the period is pi, because that's how long it takes from here to get through one cycle, okay? So the period in this one is pi. So the normal period is 2 pi, and the period for this one is 1 pi, and so B must be 2 if I reduce that relationship. So you find B by reducing that relationship. Now, there's no shift on this. If you're using a sine graph, you would have to do a shift of 45 degrees, because this is what would need to be on the axis, right? But we're not doing sine, we decided to do cosine. So C is going to be 0. D is that midline move. So how many units is it from here to the new midline? It is 2. So now that I've established the value of all those letters, I can write my equation. Y equals 2 cosine of 2x plus 2. And that would be your equation. Now, once you get this done, I would suggest that you put your calculator in radians, because this is in radians, and graph it to double check. Okay, so your calculator is going to be your best friend on this upcoming test. So, in number 2, what would minus 1/2 change the graph? Again, your calculator is going to be your best friend. I would put this in. That's your parent graph. And then I would put this in. And I would see the difference. So did you do that? What was the difference? What was the shift on that? Was it 180 degrees? Or was it 90 degrees? Was it pi? Or was it a half pi? What was the shift? You don't know? Okay, so here's how you need to do that one. Take a look at your calculator. Okay? Looking at your calculator, here are your graphs. Actually, I'm going to use the calculator on the screen up here, so it will record. So here's my calculator. I'm going to graph the sine. First, my mode needs to be in radians, and it is. So I'm going to graph the sine. Y equals sine x. And so I'm going to look at that graph. That's what that graph compares to. Okay, now I'm going to look at the second graph. And that was y equals sine of x minus, what was it, 1/2 pi? Do you guys remember what it was? 1/2 pi, minus 1/2 pi. So I'm putting it in just like you see it, so that you don't have to do much thinking at all. So I wanted to see what this graph looks like. So I know that's the original. Look at what that's doing. That's shifting to the right 45 degrees, isn't it? Or pi over 4, right? Yes. Yes? So that shifted to the right pi over 4. And that's what you need to write. Okay, there is a shift. Now there is more than one correct answer, as long as you're describing it correctly. One-fourth pi. Okay, number 3, in the standard form A cosine bx minus c, what does the letter c affect? And it would affect phase shift or horizontal shift, because those are the same thing. Use the law of sines and the law of cosines if you are not using a right triangle. Now these will work with right triangles as well, but they don't have to be right triangles. So the law of sines says that if you have a triangle, A, B, C, big A represents the angle that you see. Little a represents the side across from it. Okay? And here is the equation that you will need to take a look at. So if you're watching this on video, go ahead and pause and get that copied down, because you will need to turn these notes in. Okay, so here's our practice problem. And this is definitely a calculator problem. So if you don't have your calculator in your hand, you'll want to get your calculator. And then we want to take a look at our triangle. This is not a right triangle. You'll see that this is big X, so little x will be the one that we're going to have opposite that. So this is little x. This one right here is little x. So we're going to take a look then at little y is the one that we're looking for. So the sign that we want to take a look at, I don't know why that's not doing yesterday, is sine see if I can make a little notepad over here to write on. So sine of the sine of 29 degrees is the one that's opposite that. So according to the law of sines, it would be y, little y, over the sine of 29 degrees. That's big Y. Okay? And that's going to be equal to the one that we have. So the information that we have is the 13. So we're going to put the 13 on the top, and the angle opposite the 13 is the 128. So it's going to be sine of 128. So in your calculator, put your mode to degrees. Why are you putting your mode to degrees? Because it's in degrees.
Let's go back to that.
So I want you to be careful about what you put in your calculator, because I don't want you to mistype anything. So as you get your calculator handy, I want you to put in your calculator. Our mode needs to be degrees. And now we're going to do cross products. So it's the sine of 29 times 13. Now notice I'm not pressing equals. You could, but then you'd have to do more keys. So y, so times 13. And then don't we have to divide by this piece according to cross products? So if you just hit divide now, the sine of 128. And close your parentheses. Okay? So what we've done here is cross products. So if I'm taking a look at this one, it's the sine of 29 degrees times 13 divided by the sine of 128. And that's going to be equal to y. Okay? So you can see that really is, can you put all this in the calculator? So then let's press enter. And we get 7.998. Now, the directions on this say round to the nearest tenth. So 7.9 is going to round to what? 8. Okay? So part of it is going to be a rounding issue. Okay? Let's try another one. I'm going to pause here, and I want you to see if you can set up the ratio for this one. All right, so for our new problem, hopefully you set this one up. We're looking for G. So if we continue to look for G, we need to set this up as G over the sine of 49 equals, and we want to look for one that we have already, so you'll want to use the 7 and the 24. So 7 over the sine of 24. So it is very important that you pay attention to the angle and the side opposite the angle. The angle and the side opposite the angle. And the law of cosines is going to be the same way. So as you set up your calculator piece, you will need to do the sine of 49. It's still in degrees from the last question, so we don't need to worry about that. So the sine of 49 times the 7 divided by the sine of 24. And you could even set this up as a fraction, just so that it looks kind of like what you're doing there. Sine of 49 times 7. And you want to divide that by the sine of 24. And press enter. So this length looks to be about 13 because we have to round it to the nearest tenth. So we're going to look at this digit. This one goes up 1, and if that goes up 1, it's going to be rounded to the 13. So 13 is what we're looking for. Okay, good? All right. Now, there is something I want to point out, and we haven't done a question yet that requires us to do this. But once you get your score up a little higher, it will require that you are able to calculate the measure of that third angle. So what requires, or what property, way back from geometry, it was the triangle sum theorem. I think I heard somebody say that. Remember that all three angles must add to give you 180. So if you needed Q because it was looking for little q, you would need to use the triangle sum theorem. Okay? So again, once your score gets a little higher here, they are going to ask you to do a little more thinking. But for the triangle sum theorem, that really is kind of the gist of it. So now let's take a look at, yes, as we kind of move forward, sometimes you don't have the information to use the law of sines. You can see the law of cosines is a bit more complex.
Wait, so
I'm going to tell you that the only time you use the law of cosines is when the law of sines won't work for you. Okay? Now, I'm not going to ask you to memorize this. You see it's on the board. It will be on the board for testing too. I will not ask you to memorize the law of cosines. The law of sines is easy. The law of cosines, know which one is A, which one is B, and which one is C. And I'm going to tell you, it really doesn't matter. As long as little a is across from big A, little c is across from big C, and little b is across. So you can label the triangles anything you want. The letter, the lowercase letter, is the side across from the uppercase angle. And that's what you kind of need to realize. So let's practice. All right, so here is the law of cosines. So you can see that we are looking for a little s, and we are only given one angle measure. Okay, so we can't use the triangle sum theorem to find the other two. So we're pretty much stuck using the law of cosines, because that's what I was telling you earlier. If you use the law of sines, it is easier. Okay, so let's take a look, knowing that we need to use the law of cosines here. So here's our worksheet. Let's see if we can get it kind of smaller again so that we can see around it. Here we go. So we need to use the one that's this one squared, because you notice in the law of cosines that you copy down, every single side that you were given was b squared cosine of b, c squared cosine of c. So that's a pattern, right? The measure of the side opposite the angle that you're giving is how you need to set that up. So we would set that up as s squared equals 13 squared plus 11 squared minus 2 times 13 times 11, right? It's times the two sides, times the cosine of 108. Okay? So I really just filled in the formula that you just wrote down. It's the side that you're looking for is by itself, and that's squared. And that's the other two sides squared minus 2 times the other two sides times the cosine of 108. So now we're ready to pull out the calculator. And again, our calculator was already in degrees, but let's double check the mode since okay, so it's still in degrees since it was sleeping. So 13 squared. And I'm actually going to go ahead and do the square root of this, because then I have less things to enter. And a length is only going to be positive, so I don't need to worry about plus or minus, because this is a length. When I take the square root aside, you know I have to have plus and minus, but a length will only be positive. So I'm only worried about the positive of this. So this is actually what I'm going to put into my calculator. And I'm going to do that all in one step to avoid trying to enter some things. So the square root of 13 squared plus 11 squared. Now you can go ahead and do those, 169 and 121, if you're confident in your calculation skills. 2 times 13 times 11 times the cosine of 108. So it really is just, can you fill in the formula? Okay? It really is just, can you fill in the formula? And so this is 19.5 if we are rounding it to the nearest 10th. Right? 19.5. Yep. It's not 119.5. That would not give me the right thing, would it? Say it again. This one didn't give us enough information to use sine. You need at least 2 angle measures to do sine. This one only gave us 1 angle measure. Okay, so the question was, look back at the calculator.
Oh, wait, can you put that the work back up?
The key sequence back up.
And you said our calculator has to be in degrees for all of this? This one and the log, cosine? I mean, sine?
It depends on what they give you the angle measure in. They will typically be degrees. Okay, did you do, we're looking for V. So I'm going to say V equals the square root of 15 squared plus 15 squared minus 2 times 15 times 15 times the cosine of 19 degrees. Is that what you got? Okay, it is a calculator. Yeah, I'm not going to collect it, but I am going to come around and give you points for it. Okay? I want you to keep it. So the square root of 15 squared plus 15 squared minus 2 times 15 times 15 times the cosine of 19. And that is going to be 5 if we round it, isn't it? Because you have to look at this. This goes up 1/10 more than 4.9 is 5. So that would be 5. Okay? Did everybody get 5?